So, 3.
I want to go to the bathroom.
Oh,
Yeah,
I
go.
got the B part right.
So, ladies and gentlemen, here we are going over last night's homework. We were talking about standard error of the mean. We were talking about populations. We were talking about inferential statistics, right? Yeah, there we go. And here we got this question. It says, if the standard deviation, man, that's how you have to read data, by the way. If the standard deviation of a sample set of data is 5.6, so there's my little sigma,
Blah, blah, blah,
is 5.6. That sigma could use a bigger tail on it. There we go. And the standard error of the mean, so there's my sigma sub x bar, is 0.056. The question is, how many values are in the set? N equals unknown to us. So the formula I'm using is sigma sub x bar is equal to sigma divided by the square root of n. And a classic algebra problem here. We plug in what we know to solve for what we don't. 0.056 is equal to 5.6 divided by the square root of n. And what I will do is solve for n. I might multiply both sides by root n just to get it out of the denominator. You could also consider that multiplying both sides by the LCD to kill the fractions, but there's only one fraction to begin with, so. And then I have the square root of, or 0.056 square roots of n. That wasn't going to be an n. There we go. There's an n. Equals 5.6. And then I would do what to get n by itself? Divide by 0.056, 0.056, and I would get square root of n is equal to 100, I believe, if I'm not mistaken. So to solve for n, what would I do?
Square. Stand up and scream there.
Square both sides.
Oh.
So n is equal to 10,000. Right, so all they were doing was having us use a formula we knew backwards. Right?
Backwards K.
That's all. So, un otro problema. What was it? What do you guys want me to do from this lower set here?
20. 20. 20. 20.
I'll do 20 eventually, but should I start there?
Yep.
Okay. I'll start at 20, I guess. And we're looking for an interval about the sample mean that has a 1% level of confidence. LOC.
Yeah, I totally did all my 68.
Keep it. Oh. Everybody loves pie. So let's label what we know. So if the LOC is 1%, what does that mean for our P value? 99% is the value of P. So I'm going to have to look up some T value with relation to that, which I think is 2.576. And I'm looking for a T value here. They're also not homemade. They're made in the factory. Yeah.
Yeah, go to Levante.
Yeah.
So cool.
Count it down the sunset. Take it away, Squidwards. So I know sigma, I know n, I know x bar, but do I know sigma sub x bar?
M.
Actually, let me do that in purple for fun. Sigma sub x bar is going to be 11.12 divided by the square root of 1,000. Am I right? 110 isn't coming into play here just yet. Square root of 1,000 is not going to be 100, sadly. Square root of 10,000 would be. So it's 31.622 blah blah blah, and then I'll do 11.12 divided by, skip to the loo, and I get 0.3516 is sigma sub x bar. All right, so there's sigma sub x bar once it's calculated. So let's draw an actual distribution. I guess I'll draw a quick little picture here for us. You guys are fans of pictures. I might not actually calculate all these values, but my mean is the 110, and then this would be 110.3516, and then blah, 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 and blah, 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 and blah, blah, blah. So this is not the distribution of data. This is the distribution of possible true mu's. I'm looking for mu, right? Because we're using a sample of a population of 1,000 people and making inferences about the entire population. Right. So if I have a 99% level of confidence, I'm trying to figure out what values, all right, what is the range that's going to give me 99% of the data about the mean. And that's why I chose a t-value here. And now I've got everything I need to figure this out. My range is going to be calculated by doing x bar plus or minus my t times my sigma sub x bar. So that will be 110 plus or minus 2.576 multiplied by 0.3516, right? So let's go back to the old calculator. And I will do 2.576 times 0.3.
You screwed up.
Yep. Sometimes the buttons are a little unresponsive. Times 0.3516. Enter. So this, what does this 0.9 represent? What is it measured in? Well, standard deviations was the 2.576. 0.905 blah 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 is the number of units above and below the mean. So this is measured in units. All right. So 0.9057, I guess. Plus or minus 0.9057, right? So my upper bound will be 110.9057, and my lower bound will be what? 109 point. What's that going to be? 1 something? I'm always bad at the maths. I'm bad at the maths, guys. 110 minus second ants. Yeah, 0943. There we go. 0943. So it's right pretty close proximity to what our sample mean was. So I'm like 99% sure that the true mean is in this range. All right. So that's the idea. I'm finding a range for which the true mean is likely to be based on a certain percentage. Right? I mean, if I only wanted to be 10% accurate, then I would have a different range. But I narrowed it down. And sigma sub x bar will become narrower and narrower, right? A better and better number, smaller and smaller, the more values I get, because sigma sub x bar is calculated by dividing by the square root of the number of people or pieces of data that I have. So the larger my sample, the more accurate my mean will be in approximating the true mean. Right?
So big
Right.
the end
What?
values? Big the end values?
Yeah. Right? So if I survey 10 people compared to 100 people, I'm going to be more accurate with 100 people. To figure out what the true mean was. Looking for the true meaning of life.
Answer the life is
So anyways, I think that might be all we need. I'd rather have us get going on reviewing for some examen mundi lunes, right? All right, am I right? So let's cut this internet. Bye, internet.